Woo! Today's video is going to be about polynomial inequalities. Let me get rid of these smudges here. Right now, we've been, in mathematics, we've been dealing with inequalities and equalities, but now we want to be given some sort of expression like, let's say, x squared minus x, and we want to see when is this value greater than 20. Meaning, we aspire to find the solution set. What is the solution set? The solution set is all the values of x we can choose that satisfy this equation. For instance, a value that is not in the solution set is 0. So, if x is equal to 0, this would imply 0 squared minus 0. Is this greater than 20? No, because this is just 0, and this would imply that 0 is greater than 20, which is not true. So the value x is equal to 0 is not in there. But let's say x is equal to 10. 10 is here, for instance. If we take a look, x is equal to 10. I have 10 squared minus 10. Is this greater than 20? Well, this is 100 minus 10, which is equal to 90, and this is in fact greater than 20. So the value x is equal to 10 would be in the solution set. However, we don't just want to pick 1 point, 2 point, 3 point, and do this on forever in an infinite fashion. We aspire to find some sort of method that would allow us to find all of the values that would satisfy, all the values of x that would satisfy this inequality. And for that, we just need to do some algebra. Take a look over here at this inequality, x squared minus x greater than 20. If I subtract the 20 from both sides, I get x squared minus x minus 20. And the inequality stays the same because I didn't multiply or divide by a negative number. Now, what we must do is basically treat this almost like an equation. Because if we figure out when is x squared minus x minus 20, if we figure out when this is equal to 0, we'll be able to pick values slightly larger so that it will be greater than 0. We really have this situation here, but we can pretend to have this situation, use the algebraic methods and tools and skills that we've already discovered how to use, find out those roots, and then pick values a little to the left or a little to the right that will actually give us the real values that we want. So x squared minus x minus 20. X squared minus x minus 20. Okay, let's set it equal to 0. How would we factor this? Well, one way to do it is to factor it directly and say, well, I need two numbers that multiply to give me 20, but add to give me negative 1. Well, I really can't think of two numbers that do that, so I'm going to complete the square. So what I'll do is I'll add this 20 to both sides and get it here. And over here, I'll do the complete the square process. That's get my b divided by 2 and square the whole thing. So I get 1/4. Okay? So I add this 1/4 piece to both sides of the equation. Now, the left side factors to x minus 1/2 quantity squared, and that equals, multiply top and bottom here by 4, I get 80 plus 1 divided by 4, which is 81 divided by 4. Okay? 81, that's 9 squared, so this is equal to 9 squared divided by 2 squared. 9 is really 3 times 3, so that's 3 squared, so this is 3 squared raised to the second power all over 2 squared. So this doesn't really break down anymore. Okay? Because I broke it down into the prime factors. That is the same thing as 3 to the 4th divided by 2 squared, which nothing can cancel. So we're stuck at 81 divided by 4. Next, we take the square root of both sides here. So I get x minus 1/2 is equal to plus or minus the square root, plus or minus the square root of 81 over 4. 9 is the square root of 81. 2 is the square root of 4, so I get the ratio 9 over 2 here. Okay? Next, I add that 1/2 to both sides. So I get x is equal to 1/2 plus or minus 9 over 2. We can combine them under the same denominator, which means that x is equal to 1 plus or minus 9 all over 2. Okay? Now, we're still aspiring to find the solution set, and we haven't found the roots yet. First we got to find the roots, then we can find the solution set. So let's bring those values here. We'll get x plus is when we elect to add, so that's 1 plus 9 divided by 2. This is 10 over 2, which results to 5. This is equal to x plus. Okay. Then we got x minus, which is equal to 1 minus 9 all over 2, which is equal to negative 8 all over 2, which reduces to a negative 4. This is our x minus. Okay? So our two roots are x equals 5 and x equals negative 4. Now, we analyze where our roots are on the number line. We create a reference point 0. We find negative 4. We find positive 5. And the way to establish a solution set for this inequality is we know that negative 4 and positive 5 result in this expression equaling 0. So those can't be picked because it needs to be greater than 0. So we must pick values to the left, in between, and right. To the left, in between, and to the right. So maybe I should put the in-between part here to highlight the difference. Or else it just looks like one big long squiggly. To the left, pick a number. In between, pick a number. To the right, pick a number. Okay? So let's pick a number to the left. Easy to see number here is negative 5 lies right here. So let's plug negative and 5 for x and see if it results in a contradiction or not. Negative 5 squared minus negative 5 minus 20. Is this greater than 0? I'll put a question mark. Well, this becomes positive 25. This becomes plus 5. This becomes minus 20. So this ends up being, is this greater than 0? That's what we want to know. Well, 25 minus 20 gives me 5. 5 plus 5 is 10. So this is 10 is greater than 0. And it is. So this value works. So I put a check mark on that value. Now let's pick a value in between negative 4 and 5. Let's pick a 0. 0 is always an easy number to use. So clear up some real estate here. 0 is easy because when we plug in 0, many of the terms drop. So I'll plug in 0 squared minus a 0 minus 20. Is this greater than 0? Because our original function was x squared minus x minus 20 is greater than 0. This was our original that I erased. Okay, so is this value true? Indeed, it is not, because now we get negative 20 is greater than 0, and that is not a true statement. So this middle part does not work. This middle part does not work. So we don't want to have that part included. Okay? So next, now we want to pick something right here to the right. Maybe 6. You could pick 7, you could pick 8. You just don't want to pick larger numbers because it makes the arithmetic more difficult. So now I plug in 6 in for these values. 6 squared minus 6 minus 20. Is this question mark greater than 0? Well, this is 36 minus a 6 minus 20. Is this greater than 0? Well, this is 26, negative 26. So when I subtract that, I just get 10. Is 10 greater than 0? Indeed it is. Indeed it is. So these values work. So the values in the middle and these endpoints do not work because at these endpoints right here, it is equivalent to 0 and we want it to be greater than 0. So to the left of this and to the right of that, we get values that work. So our solution set, we may assert, is, there's no question about it anymore, the solution set is equal to all the values to the left of negative 4, but not including negative 4. That's negative infinity to negative 4. Union, all the values to the right of positive 5, but not including positive 5. There we go. And here is our solution set. The way you do these problems is you set up your inequality, you treat the inequality like it's equality, then you put your points here on the real line and you pick points to the left, to the middle, or to the right of the roots. You include the root values if the inequality is greater than or equal to or less than or equal to. If there is no equal to part, you don't include those root points because we want it to be strictly greater or strictly less.